In this video, I'm going to cover on your module 5, which is on the combination logic circuit. We already finished module 4, so we're straightly going to look into module 5. In this module 5, after that, we're going to do the lab 2. But before that, we need to finish our module 5, which is a combination logic circuit. So in this module, what you need to going to learn is NO inverse logic, and then you're going to learn on conversion between different representation of digital circuit, and introductions on the universality of gate, and then on the dual symbols and digital circuit, and lastly going to learn on design a combinational circuit. So first thing in this video, we're going to cover on basic combinational gate. So what you're going to look, which is on NO logic and also NO inverse logic. So it is quite easy basically, because you already learned in your chapter or module 1 and also module 3. So in here, what you need to do is you need to design a circuit, which is normally we only have two possibility, which is your output will be 0 or also 1, because in binary you only have two possibility, which is 0 or 1. If we want our output to be active, then your final circuit will be have a SOP. Why SOP? Because it is the output 1. Please look back on your module 4 if you have difficulty on why you need to have SOP for active output. And this kind of circuit can easily be implemented using NO logic. So you need to know SOP normally use the NO logic. While for your logic, which is low output, normally of course it will be POS, and you're going to use NO inverse, which is the inverse of course for the NO logic. So over here you can see this is your N, and then this is your O logic. I guess this is we already repeat many times. And your SOP expression, this is how the SOP expression, if you have N get and O get, this is just example how SOP representation. And if any of N gates output are high, the output of O gate is high. And if all the N gate output is low, the output O will be low. This is a simple thing that you can understand, because you know N gate will be having output 1 only when both input is 1. Similar also vice versa. So your output will be 1 only when all your input is 1. For your output of your N gate. So over here it depends, because this one is O gate. This one is the one that I mentioned, which is about N gate. So over here, there are example. If let's say your output here is 1, you will having 1, and if your output is 1, at least 1 from your O gates input, so you will be output of 1. So this is the output for your NO logic based on the truth table expression. Derive, you need to derive and simplify it using your CAMAP. As mentioned, CAMAP is the rules or a method for you to use if you want to simplify your Boolean expression and also your logic circuit. And then you're going to implement using NO logic. So if you look over here, there is a part which is write the Boolean expression or map the one which is one output to the K-maps. So you will get the SOP. So from here you can see this is the output one. So you will draw it using your K-maps over here. And you will get AB plus CD if you draw it correctly. So this is how you will get, basically this is the long equation for your output X, but after you use K-map you're going to simplify it and you will get only this, which is AB plus CD for your X. Simplify the expressions using Boolean algebra. So over here you can see that this is the associate law, similar to this one. Please check back on the law over here, and you can use the rules. This one is how you're going to simplify it and test your answer, how you're going to simplify using a Boolean algebra. So lastly, you're going to get the same answer similar if you use the K-map. K-map is using this step only, one step, and you will straightly get this, but using you can see Boolean algebra rules, you're going to see a lot of steps you need to make. So over here it is a AND or inverse logic. You can see it is a complement AND or circuit, of course, because there is not only in front, that is the difference. So actually it is like this, and the result is a complement of AND or circuit. So that's why you will having the P or S instead of S or P. So this is a truth table. You can see over here a complement of AB plus CD. So you can try to draw the SOP K-map, and also you can also pick the POS K-map also. This one is already done in your module 4, so I guess it's not having a difficult things for you to simplify it. So let's say you were given this one similar truth table like this, so you need to take out the low output. You can see over here, because you want it to have only the low output. Sorry, because okay, this one is the one that you were given in the slide 12, not this. Okay, this one is your from this truth table, and this output you're going to do the inverse. This is your X, and then after that you're going to do an inverse to implement the active low output. So this is your X over here, and this is the X bar here and here. So after that you're going to take your low input and active low input. So what is the meaning by active low input? Because basically it is a high input, and then you convert it, it become a low, it's a 0. So based on the truth table, you can describe it using your K-map and simplify it, and then you implement the AND or inverse logic. So if we want active low, put the inverse in the output. So you can see over here, you put the inverse of the output SOP circuit. It will produce POX for X bar. Okay, you need to see that not POS for X. So don't take this O0 over here for your POS, but you need to pick the 0 from your X bar to get the active low input. This is the meaning of active low input. Normally for POS, you directly use this one in your module 4, right? But the term of active low is the X bar of your output, and you pick the active low. This is the active low. So from here, you're going to draw your truth table and also CAMAP. You will convert it to your CAMAP, and you will get the POS term expression. That's why you will get the output for your CAMAPs, the simplified version. So this one also you can try to do it. You have given truth table, and of course if you need to have AND or inverse logic, you need to do the inverse part over here and pick the active low. Okay, is it this one is active low, this one is active high? So you will get this. Please try do it by yourself also. And another one is on the universal property of NAND and also NOR gate. You can see over here, if a gate can be converted and perform the functions of basic gate, then it can be used to implement any logic circuit. Therefore, it's called as universal gate. So there are two common universal gate, which is NAND gate and NOR gate. This one also you already looked into your module 3. So you can go through this one. You can read, because I'm not going to read all the sentences. If not, that it's easy for me to be a lecturer just reading the slide. So the keywords that you need to note is on about universal gate is AND or also NOR. So normally SOP will implement using NAND gate only, while POS will be using NOR gate. Is okay? That's the big difference between SOP and POS. So what is basically NAND gate? NAND gate is the inverse of AND gate. So you will having like this. It's used for an inverse. So if you have a 2 NAND gate, so you will get AND gate. This one is basically how you represent your logic elements. And if you have these three, how your output will look like. Basically, these three NAND gate is similar to the OR gate. And then you have this type of logic gate, a combination of NAND gate, you're going to get the OR bar, or called as NOR gate. So please try to read this on what is the keywords. That's why you will get like this part, this one is NAND or NOR. So you have 4 possibility using an NAND gate. One, you will get NAND gate, you will get NOT, and then 2 NAND gate, you're going to get AND gate. 3 NAND gate, you're going to get OR gate, and lastly 4 NAND gate, you're going to get a NOR gate. So this is basically the summarizations. And there is exercise. Use the NAND gate to implement each expression. So let's say question number A, you have A bar plus B, so you can have A bar over here and then you plus with B, which is using a OR gate. Or using the NAND gate over here, you will notice that you are using one NAND gate. And OR gate, you need to remember OR gate is going to have 3 NAND gate. This one is represent as OR gate. So lastly, you will get like this. And after you simplify it, you can just make it as 1 or direct from here, and this part also is 1, because this one is basically 1 direct, which is you inverse, you will get A also. So you just remove it because it's a direct A, and then you will having this part similar, and this is the minimums of logic NAND gate from your NOT and also OR gate. So question number 2, you can try it for B, how you get, and there is another also exercise. Please try it, and this is the answer. You can try it, how you going to implement. Over here it is about NOR gate. Last time you learned on NAND gate, now it is NOR gate. Similar also, you can have NOR gate, and one NOR gate you're going to get not 2 NOR gate, you're going to get OR gate. For if let's say it is a NAND gate, you're going to get AND, right? So please make sure you understand this difference between NOR and AND. So if let's say over here you have 3 NOR gate, you're going to get AND gate. If this one is NAND gate, you're going to get what? OR gate. So if let's say you have 4, then you will get the NAND gate. While if you have NAND gate for 4, you will get NOR gate. So this one is similar. Please try to do it. If you have this, you just represent it similar with the solution given for the NAND gate. So on dual symbol, I think this one I'm not going to cover it in this video. I'm going to make this video short, so you can have more time just to do a revision on that. Later on, I'm going to share you another half video just to finish on your module 5. So I'm going to make it slow as long as you have the understanding on what you have learned. Is it okay? So if you have any question, you can direct ask me, WhatsApp me. If maybe I miss your WhatsApp, please just re-WhatsApp me. Is it okay? So thank you for your watching and have a good day. Bye bye.